students, we are doing trigonometry 1 chapter number 2 from paper 1, and today we will see a next point, which is a periodicity of a trigonometric function. Periodicity of a trigonometric function. So first we will see the definition of a periodic function. A function is said to be a periodic function if there exists a constant p such that f of x plus p is same as f of x for all x in domain. So any function is said to be a periodic function if there exists a constant p such that f of x plus p is same as f of x. That means suppose p is equals to 2. So f of x plus 2 will be same as f of x. Okay, तो अगर तुम 2's में ऐड करते हो, constant p ऐड करते हो, so it doesn't affect the value of the function and it holds for every element in your domain. Then that type of function is called periodic function with the period 2 p, not 2, with the period p. Okay. So a function is said to be a periodic function if f of x plus p is equals to f of x and it holds for all x, and hence it is equals to f of x is same as f of x plus p, which is same as f of x plus 2p. Means you can add a multiple of p. Okay. Then f of x plus 2p, f of x plus 3p, and so on. And here also it is equals to f of x minus p, which is equals to f of x minus 2p, and so on. So you can add p or you can subtract a multiples of p. It will give you a same value. Then your function is said to be a periodic function with a period p. Okay. Now all the trigonometric functions. Okay. So we have sine x plus 2 pi. I am giving you one example of sine. This is the general definition of a periodic function. Now I am giving you sine theta is your function. Okay, so suppose this is your theta, sine theta, or take sine x where x is any angle. Okay, and I am giving you 2 pi. I am giving you 2 pi as constant t. So sine x plus 2 pi, sine x plus 2 pi will be same as sine x plus 4 pi, which will be same as a sine x, which is equals to sine x minus 2 pi, and same as sine x minus 4 pi, and so on. Okay. So the sine is a periodic function with a period 2 pi. So you can take any value for the x, you can add 2 pi over it, then you can see the value of sine x and value of sine x plus 2 pi is what? Same. So therefore sine is a periodic function with the period 2 pi. So similarly we have all the trigonometric functions which are periodic in nature. So directly they have given us their period, okay, without any proof. Just we have to remember their period, which can be used while solving example. So I am just writing a period and the functions. Okay, so the function first sine theta, then cos theta, then tan theta, cosec theta, then a sec theta, and a cot theta. So period for sine theta is a 2 pi. Always remember this. Okay. So the sine theta will be same as sine theta plus 2 pi. Sine cos theta will be same as cos theta plus 2 pi, and so on. Similarly, period for cos theta is 2 pi. the next class we will see a graph of a trigonometry function. But today we will solve the problem from exercise and from solve problems. So I am doing problem number 1, page number 25. Problem number 1, page number 25. Find the value of, this is problem number 1. Find the value of sine 41 pi upon 4. Okay, so you have to find the value of 1 pi upon 4. As we know, you have to write solution. We know sine is a periodic function with a period 2 pi. Right? So sine 41 pi upon 4. Now what we will do? We will try to split this into addition of 2 pi. Okay, in the form of 2 pi. So what we will do? See, this 41 can be written as 10 pi plus pi upon 4. Right? So you can see here 10 into 4 is 40. 40 plus 1 is 41. So this is 41 upon 4. So I have split this term into 10 pi upon 10 pi plus pi upon 4. And we know that it is sine is a periodic function with a period 2 pi, and here 10 pi is a multiple of 2 pi. Yes, so it will only sine pi upon 4. I hope this is clear, because sine x plus 2 pi is same as sine x. Sine x plus, you can take multiple, 2 pi, 4 pi, 6 pi, 10 pi, it will be only sine x. Okay, so I am writing only sine pi by 4, and sine pi by 4 is 1 upon root 2. So this type of problem can come in exam for 2 marks. Okay, now the next is find the value of cos 765 degree. This is problem number 2. Cos 765 degree. Again we know that cos is a periodic function with a period 2. So now what we will do? We will convert this 765 into multiple of 2 pi. Right? So same statement you have to write. Cos theta is a periodic function with a period equals to 2 pi. Right? Therefore, cos 765 degree is same as cos 765 can be written as 720 degree plus a 45 degree. Right? Now 720 is equals to how much? 2 into 360 degree plus 45 degree, which is equals to cos 2 into 360 means equals to how much? It is equals to a full rotation, that is a 2 pi, right? 2 pi plus, so that means, see, this is a multiple of a 2 pi. So we can directly write its answer as cos 45 degree, so which is 1 upon root 2. How simple it is. Okay? So from exercise, let me check if the similar type of problem is there. No, there is no problem based on this period in your exercise. Okay. Now the next problem, we will solve the next problem. It is page number 26, problem number 1. Page number 26, problem number 1. So the problem is if tan theta plus 1 upon is equals to 2. Then find the value of tan square theta plus 1 upon tan square. Tan square theta plus 1 upon tan square theta. So it is given that tan theta plus 1 upon tan theta is equals to 2. You have to find out the value of this expression. So we will start from here. Tan theta plus 1 upon tan theta is equals to 2. We need square terms. Okay. So what we will do? Squaring both the sides. Squaring both sides. What we will get here is a plus b whole square, right? Tan theta plus 1 upon tan theta whole square is equals to 4. 2 square is equals to 4. So now we will apply formula here. So it will be tan square theta a square plus 2 times a into b plus b square. 2 times a is what? Tan theta. B is what? 1 upon tan theta plus b square means 1 upon tan square theta is equals to 4. Now this term and this term get cancelled. So you will left with tan square theta. This tan square theta. Here it is plus 1 upon tan square theta is equals to 4. And here it is 2. Right? So it will be minus 2. So answer will be 2 only. Okay? This is very simple problem. Now we will solve a problem number 3 from page number 27. There are many problems of this type in your exercise. Okay, so first we will solve problem number 3. What is given there? If 5 tan a is equals to root 2, a lies between pan and 3 pi by 2, means it is in third quadrant. Okay, your a is in third quadrant and 5 tan a is equals to root 2. Set b is equals to 11, where root 11, where b is in the fourth quadrant. Then find the value of cosec a minus tan. Okay, so here there are two angles. There are two angles a and b. The first angle is in third quadrant and the b angle b is in a fourth quadrant. Also 5 tan a is equals to root 2 and sec b is equals to root 11. We need to find cosec a minus tan b. So we have tan a. So from tan a we can find, we have expression. So we will start solution. Given, always write given things. Okay, so the 5 tan a is equals to root 2. Therefore tan a is equals to root 2 upon 5. Okay, so if tan a is equals to root 2 upon 5, that means a tan and a cot, reverse of each other. So we know tan theta, cot theta is what? 1 upon tan theta, right? So the value of the cot a will be what? 5 upon root 2. Okay, next we know that 1 plus tan square theta, sorry, we have value of tan theta. Okay, so no need to use this expression. We will use this expression. Cosec square theta is equals to, not theta, is equals to a, because here the angle is given as a. So we have to use that notation only. Cosec square a is equals to 1 plus cot square a. Okay, cosec square a is equals to 1 plus cot square a, and we have value for cot a as 5 upon root 2. So it will be 1 plus plus 5 divided by root 2 whole square, which is equals to 1 plus 25 divided by 2. That means take the cross multiplication. 2 plus 25, 27 upon 2. So here is cosec square A is equals to 27 upon 2. Therefore, see 27 can be written as 9 into 3 divided by 2. So cosec square A is equals to 9 into 3 divided by 2. If you take square root, so you will get cosec A as, see, under root 9 means 3. 3 under root 3 by 2. And here the A is in third quadrant, therefore sign of cosec will be minus, because cosec is minus in the third quadrant. So we have got cosec. Okay. So cosec A is done. Now we need to find tan B. So value of cosec A is minus 3 root 3 upon 2. Now we will find, not 2 upon root 2. Sorry, this is upon root 2. Okay. Now we will find, to find value of tan B, what is given to us, sec B is equals to root 11. Sec B is root 11. Therefore, tan square B is equals to sec square B minus 1. Okay, that is under root 11 square minus 1, which is equals to 11 minus 1, that is a 10. So tan square B is equals to root 10. Therefore, a tan B is equals to root 10. Also, B lies in a fourth quadrant. Okay, B lies in the fourth quadrant, so it must be negative. So the value of tan B is root 10. Now we will minus root 10. We will put these values. You can give this as equation 1 and the value of tan B as equation number 2. Okay, so from equation 1 and 2, from 1 and 2, what we have to find? We have to find cosec A minus tan B. So what is value of cosec A? It is minus 3 root 3 upon under root 2 minus root 10. So this is your final answer. Okay, so the value of cosec A minus tan B is minus 3 root 3 upon 2 root 2 minus root 10. So similar type of problems are there in your exercise. Exercise 2.2, problem number 1. Same problem is given. Two angles are there. You have to find value of one expression. So you just need to use that three expressions, three identities, fundamental identities. Okay. So the first problem and the third one is for your homework. Just try to solve it. Now we will solve a next problem from page number 27, problem number 4. Okay, so the question is, if this is problem number 4, page number 27, if tan theta is equals to 1 upon root 7, then evaluate cosec square theta minus sec square theta divided by cosec square theta plus sec square theta. Okay, it is reverse of this. Now we know that since we know that cosec square theta is equals to 1 plus cot square theta, right? In previous lecture we have seen this identity also. A sec square theta is equals to 1 plus tan square theta, right? So suppose this is your 1, this is your 2. So what we need? We need cosec square theta minus sec square theta in numerator, right? So we will subtract 1 and 2. What you will get? Cosec square theta minus sec square theta. Okay, in LHS cosec square theta minus sec square theta. In RHS 1 and 1 get cancelled. You will left with cot square theta minus tan square theta. Right? Suppose this is your equation number 3. Now we need addition of cosec and sec in denominator. So again we will add 1 and 2. So if you add 1 and 2, you will get cosec theta plus sec theta is equals to 1 plus 1 is 2 plus cot square theta plus tan square theta. This is your 4. Okay. So this is numerator, this is denominator. So we will divide 3 and 4. So you will divide 3 and 4 to get this expression. So divide, I am writing here, divide 3 and 4, what you will get? Cosec square theta minus sec square theta divided by cosec square theta plus sec square theta. And in RHS, you will get cot square theta minus tan square theta divided by 2 plus cot square theta plus tan square theta. Now we have value of cot and value of tan, so we will substitute into this. So what is value of tan? 1 upon root 7 and value of cot is root 7 only, right? So we will substitute in this. You will get, so cot is equals to root 7 whole square minus 1 upon root 7 whole square divided by 2 plus root 7 square plus 1 upon root 7 square. Okay. So solving this, I am writing here. So this is your expression. Cosec square theta minus sec square theta, cosec square theta plus sec square theta. It is root 7 square means 7 minus 1 upon root 7 is 1 upon 7 divided by 2 plus 7 plus 1 upon 7, right? Which is equals to 7 7s are 49 minus 1 divided by 7, and here we will take 7 as LCM. So here it will be 14 plus 1 plus 14 plus 7 7s are 49 plus 1. Oh, okay. So I have taken LCM 7. So you can see this 7 cancel. 49 minus 41 is 48. Now here 49 plus 1 is 50. 60 and 64. You can divide it by 2. So it will be 2 2s are 4 and 2 4s are 8 divided by 2 3s are and 2 2s are. Again 8. 8 3s are 24, 8 4s are 32. So answer is 3 upon 4. So your final answer is 3 upon 4. So similar type of problem you can solve from your exercise. Yes, I am giving you problem number. So problem number 3. Then in problem number 4, don't solve problem number 4. We will solve in the class. Just solve problem number 1, 2 and 3 from exercise 2.2. Okay. Now the next problem is a problem number 5. Problem number 5, page number 28. Problem number 5, page number 28. Okay, so the problem is prove that cos raised to 6 theta plus sin raised to 6 theta is equals to 1 minus 3 sin square theta cos square theta. Okay, problem is prove that cos raised to 6 theta plus sin raised to 6 theta is equals to 1 minus 3 sin square theta cos square theta. We will use one formula, a cube plus b cube is equals to a plus b whole cube minus 3ab a plus b. This is one of formula for a cube plus b cube. We will use this formula to solve this. Okay. Now cos raised to 6 theta plus sin raised to 6 theta can be written as cos square theta raised to 3 plus sin square theta raised to 3. Now this is your a, this is your b. Now we will apply this a cube b cube formula. Okay. Here your a is cos square theta and b is sin square theta. So this is from this formula it will be cos square theta plus sin square theta whole cube, right, minus 3 times a is what, cos square theta, then a is what, cos square theta plus sin square theta. Now you can see here cos square theta plus sin square theta is common, cos square theta sin square theta is common. So we will take that out. Okay. So here we will left with see cos square theta plus sin square theta is equals to 1. So this will be 1. 1 cube is 1 minus 3 into cos square theta. Again, just 1 minute. We have the mistake over here. This is minus 3 times a into b. Okay. So here it will be a into b means cos square theta and sin square theta. Now see, this bracket will be 1 as cos square theta plus sin square theta is 1, cos square theta plus sin square theta is 1. So here it will be 1 minus 3 cos square theta sin square theta, which is your RHS. So hence proof. Okay. So what we have done, we have just used this formula and we have used a fundamental identity, cos square theta plus sin square theta is equals to 1. So you can solve this type of problem from exercise 2.2. No, there is ऐसा कोई प्रॉब्लम नहीं है 2.2 में. Okay, just solve that 3 problems which I have given you. Okay, first, second and third. The rest we will see in next class.